Oxyacids are a special group of acids. They still start with hydrogen because they're acids, but they're combined with a polyatomic. So a generic formula for oxyacids would be H, because it's an acid, some other nonmetal, and then O for oxygen. And there might be some subscripts down here. So this is your polyatomic. Remember, polyatomics are found on page 7 of your reference tables, so they're given to you. To name these, we simply take the name of the polyatomic and change the ending. So if the polyatomic name ends in ate, we change it to ic. If it ends in ite, we change it to us, O-U-S. There's a little saying that you can use to help you remember that. Ate, I ate and got sick ick, ate to ick. I ate and got sick ick. It's all ite, you can hang with us. So ite to us. I ate and got sickick. It's all right, you can hang with us. So that might help you remember how to change the ending. Notice that we're not using the prefix hydro. So the prefix of hydro tells you it's a binary acid. So we don't use it when we do oxyacids. We're still going to cross charges when we go to write the formulas. So some examples. We have H2SO4. So it starts with an H, so we know it's an acid. It has a polyatomic because there's more than 2 capital letters. So if we wanted to, we could put parentheses around the SO4. If we look at SO4 on page 7 of our reference table, that is sulfate. And 8 changes to ic, so this is sulfuric acid. Now you might be wondering where the UR came from. Again, sulfur and phosphorus, we tend to use more of their name than just the root, just because it sounds better. So this is sulfuric acid. Now if we look at SO3 with hydrogen, so it starts with hydrogen, it's an acid. SO3 this time is our polyatomic. So we look on page 7 of the reference tables. We see that SO3 is sulfite and ite changes to us. So this becomes sulfurous acid. Let's look at another one. Here we have acetic acid. So there's a couple things to remember. Acids start with hydrogen. So we know that we're going to start with hydrogen, which is in group 1, so it has a charge of +1. And then we just have to figure out what the polyatomic is. Well, acetate, or acetic, the ic, changes back to 8. And acetate, on page 7 of your reference tables, there's actually 2 formulas. Now, I like to use the first formula that they give you. The second formula is typically used in organic chemistry, which we don't cover. So we're just going to stick with the first one. So you have C2H3O2 with a minus charge. So remember that that's a -1. And then you would cross your charges to the outside of those parentheses. And so you get HC2H3O2. We don't need the parentheses because there was only one of them. If you left parentheses there, it's fine. It's still considered correct. Let's look at another example. Nitrous acid. So again, it starts with, or it's an acid, so it has to start with hydrogen. The OUS means the polyatomic ends in ITE. Nitrous acid. So this is nitrite, which is NO2 with a negative charge, that's a -1, and we would cross to the outside of those parentheses and we get HNO2.